In this lecture, we will talk about trigonometric functions of any angles. You know, previously we have talked about that the trigonometric functions for an acute angle means this angle is only less than 90 degrees and greater than 0. But we know that angles can be any angle, can be greater than 90 degrees. Then how are we going to define the trigonometric angles, trigonometric functions for any angle? Here is the idea. You know, previously we have a right triangle and acute angle down here. We want to move this one to the standard position right here. You see, you can move this triangle to here. Okay. Then this comes to be the opposite side, y, of theta. Remember, y is the opposite side of theta, not x. X is the adjacent side. So, then this will give us what? Opposite side over hypotenuse is going to be sine. So y over r, this one is r, is sine theta. Okay? Remember, r is always greater than 0. The length. Okay? And then adjacent, the length is actually this, from here to here, this long. Okay? So then x over hypotenuse is r over y, x over r, x over hypotenuse is x over r, and that's cosine. Okay, so again here, y, not x, opposite side of theta over hypotenuse is r, y over r is sine theta. Okay, then x adjacent over hypotenuse is cosine. Then what is tangent? Tangent is then y over x, opposite side over adjacent. That's tangent. Okay. So remember, sine theta is y, starting with y. And then cosecant theta is just, you flip numerator and denominator, so you will get cosecant. Secant, you flip cosine. Okay, so r upstairs, x downstairs. Cotangent is you flip x, y. Again, y at the beginning was upstairs. Okay. Then here, you flip it, x goes upstairs, y goes downstairs. So cotangent is x over y. Tangent is y over x. Remember, our denominators cannot be 0. X cannot be 0. Okay? Yeah. Okay. This is still in acute angle. But we know angle can be anywhere if you rotate more than 90 degrees and then less than 180 degrees, this angle will be in the second quadrant. Then how are we going to define sine, cosine, tangent, and the other three angles? We would say, since here we have a y over r, let's use y over r for sine for this angle. Okay? Yeah, let's still use x over r for cosine for this angle. Yeah, let's use y over x for tangent theta for this angle. Okay? So the other two are the same. The other two are the same. So right here, this one, this angle is in third quadrant. Still, we use y over x. Y over r as sine. Okay? Y over r as sine. And y over x as tangent. And then this one, still we use this definition, but this point is in the fourth triangle, fourth quadrant, and the angle is in the fourth quadrant. Okay, so this is the general definition for any angles. So we actually extend our definition from first quadrant to quadrant 1, 2, 3, 4. Now, let's look at an example. You know, remember, sine is y over r. Cosine is x over r. And the y upstairs for tangent. So y is for sine. Now right here, this is an example. You see, find the exact values of the 6 trigonometric functions, means those 6. 1, 2, 3, 4, 5, 6. So we wanted to find exact values of 6 trigonometric functions of theta. Theta in this case is in third quadrant. If theta is in a standard position, means the vertex is an origin. Okay, this is x-axis, this is y-axis. And P is on the terminal side, right here. P -3, -4. Okay, now sine is y, as I said before, is y over r. And what is our y in this case? Our y in this case, it looks like it's no longer 3. So I'm correcting my mistakes right here. So y is, you see, this is y. -4. -3 is this one, and -4 is this one, so -3, 4. Okay, this is y. This is y. Y over r. Okay. Yeah, before we do this, we got to figure out, you know, you are only given is -3, 4. -3, 4. How long is this one? Hypotenuse. You know, x squared plus y squared is always r squared. That's Pythagorean theorem. Okay, this is x, short leg squared, plus longer leg squared, is the square root of the hypotenuse. So -3 squared plus -4 squared together is how many? -3 is 9. -4 squared is 16. 9, 16 together is 25. So that's 5 squared. So this side has to be 5. 3, 4, 5 is special. Okay? It is not the case for 4, 5, 6. Okay? Only 3, 4, 5. So we know this length is 5 and is always positive. The length is always positive. Now go back. Sine. Sine is always y. Sine is always y over r. And what is our y? Y in our case is -4 in this case. So, okay? So this is -4. -4 y over r. Okay. Cosine then is x over r. So instead of -4, here is -3. -3. Okay. And then tangent theta is y over x. So right here, y is 4. So let me put -4 right here. And here is -3. So here is 4. Here is 3. Okay? So it's easy to make mistake. And you can see here, if I'm not careful enough, I may make mistakes. Okay? So y over r. Always start with y. And then here, negative come to be positive. You can see right here, sine theta is negative here. Cosine theta is also negative. Tangent is negative over negative, so tangent is positive here. Okay, so then you see down here, we have what? We have a tangent and cotangent are positive in quadrant 3. Okay? Because cotangent is just the reciprocal of tangent. In quadrant 1, x, y are positive. So all r is also positive. So sine, cosine, tangent, cotangent in quadrant 1, all are positives. Okay? And then here in quadrant 3, those two are positive. Sine, cosine here will be negative. Okay? Yeah. All right. Now, for tangent and for cotangent, you just flip this. So 4 over 3 is going to be 3 over 4. So let me correct this one. 3 over 4. Okay? And then secant is the reciprocal of cosine. So you got to flip here. It's 5 over 3. 5 over 3 negative. And here is 5 over 4 negative. Okay, so this is the example for the new definition for any angles. Now, you may wonder, how about some quadrant angles? What do I mean by that? Look, you rotate this angle to different quadrant, 2, 3, 4. How about if you stop right in the middle? You may stop right here, here, or here. So let's look at another example and then see how sine, cosine, tangent, and the other 3, how those values would be. Here is another example. This example says that find exact values of the 6 trigonometric functions of each angle whenever possible. If there is no solution, enter no solution. And here we are given theta is 900 degrees. You see, this is apparently no longer acute angle. So where is this angle then? We don't know. We know one circle is 360 degrees. If we divide it by 900 divided by 360, here is 2. 2 times 360 is 720. 900 minus 720 is 180. So basically, 900 degrees is 2 times the divisor, 360 plus the remainder. This tells us this angle 900 degrees is rotate 2 circles, because 360 times 2 circles. And then half circles, 180 degrees right here. So I didn't sketch 2 circles, I just sketched 180 degrees. All right.